Okay, this is a video on finding the domain of an equation. It's not explicitly covered in the book, but you may find something on it in 2.3 and maybe a little bit in 2.8. So this is finding the domain of an equation. And we're basically looking at what inputs are allowed. So what x values are allowed to be put into this function? So that's why when we have a polynomial, for example, x squared minus 1, if you think about the graph of this, the domain is left to right, so that's negative infinity to infinity. So that's all polynomials are negative infinity to infinity, and that's because when you think about the graphs of polynomials, and we spent some time on this last unit, most of the graphs of our polynomials were smooth and continuous. So from left to right, all of the x values were included. So that's the first kind of type, is polynomials. The second type would be a radical, and we studied radicals. We looked at what they looked like when we graphed them. This was the square root of x. We also did things like x minus 3. So that would be, to the right 3. So the domain of this one, for example, would be 0 to infinity. And the domain of this, for example, would be 3 to infinity. It gets more complicated when we start adding in maybe a stretch or something. The way that we would do this algebraically would be, we would just say that what's on the inside has to be positive. So 2x minus 5 has to be greater than or equal to 0. If I add 5 and divide by 2, then I get 5 halves to infinity. And it can be confusing sometimes if the graph is reflected over the y-axis. For example, if we had a graph like this, let's say we had 2 minus x. This is going to look like that's 2. This is going to look like this. And the reason why that is because of the negative in front of the x. It reflects the graph over. It still has a 0 at 2 though. So the domain of this graphically we could see is negative infinity to 2. If you didn't want to graph it, which in some cases may be difficult, you would take 2 minus x, make it positive, set it greater than or equal to 0, and then I'm going to add x to both sides, so I get 2 is greater than or equal to x. That's the same as x is less than or equal to 2, which is in fact negative infinity to 2. So that's radical. And then our last type is rational. Now we haven't actually studied the graphs of these yet. So if we had 1 over x minus 1, we just know for right now that we don't want to have 0 in the denominator. So any value for x can go into this function. So all real numbers, you can write it like this, or you can write negative infinity to infinity, except x minus 1 cannot be 0. In other words, x cannot be 1. So we could write our final answer as negative infinity to infinity, x cannot be 1. If I were to maybe make this a little longer, let's see, something like this. I'm not worried about the numerator because the numerator can be 0. The bottom cannot be 0. So I would say negative infinity to infinity, x squared plus 5x plus 6 cannot be 0. So I would factor this, and I would get x cannot be negative 3 or negative 2. So that's a rational. And then we get into if we have things that are combinations. So, for example, if I said find the domain of the square root of x minus 1 over x squared minus x minus 2. Find the domain of this. There's two things happening here. The first thing is we have to look at square root of x minus 1. In this case, x minus 1 has to be greater than or equal to 0, so x has to be greater than or equal to 1. If I were to put this on a number line, this might help some of you visualize this. 1 to infinity. So here I am, 1 to infinity. But then I have to deal with the bottom, because I know that x squared minus x minus 2 cannot be 0. So that tells me that x minus 2, x plus 1 cannot be 0, which tells me that x cannot be 2 or negative 1. So I can't include negative 1, I'd have an open circle, and I can't include 2, I'd have an open circle. So I basically want to look at the overlap of this. Well, negative 1 isn't in the interval 1 to infinity, so I can just go from 1 to infinity, but I have to skip 2. Let's do another one. I could have square root 2x minus 6 plus square root of 1 minus x. If I had this, I've got two radicals in this problem. I do each one separately. I have 2x minus 6 has to be positive, so x has to be greater than or equal to 3. And I have that 1 minus x also has to be positive, so this gives me x has to be less than 1. Well, if x has to be less than 1 and greater than 3, I should have made that a plus 6. Let me change this. There we go. So if x is greater than, let's start this over. Let's just start this over. Y equals square root of 2x plus 6 plus square root of 1 minus x. I wrote the problem wrong. So this tells me that 2x plus 6 must be greater than 0, so x has to be greater than negative 3. And this tells me 1 minus x is greater than 0, so x has to be less than 1. So if x has to be greater than negative 3 and less than 1, then that means that the domain would be negative 3 to 1. Let's do just one more that has a fraction and a radical. So I can have find the domain of 1 over x minus 1 plus square root of x minus 1. And that's squared. Okay, so this says that x squared minus 1 cannot be 0, so x cannot be plus or minus 1. This says x minus 1 has to be greater than 0, so x has to be greater than or equal to 1. Well, here I'm saying x can be greater than or equal to 1, but here I'm saying x actually can't be 1. So if we think of this in a number line sense, this one is 1 to infinity, including 1. This is x cannot be negative 1 or 1. So really I have to go from 1 to infinity and exclude 1. If you wanted to write it like this, it would also be acceptable, but a little bit redundant.